from solar energy to electricity. Energy travels from the sun as particles of light called photons. Photons are packets or envelopes of energy. Different photons have different energies. Most photons from the sun have energies that fall within the visible light spectrum, but we cannot see photons with energies in the infrared or ultraviolet zones. When a photon hits a solar panel, what happens depends on the energy of the photon. Most solar panels are made of silicon and other elements. This is a silicon atom inside a solar panel. Atoms have a nucleus made of protons and neutrons surrounded by electrons. When an electron is hit by a photon with sufficient energy, it absorbs the energy from the photon and breaks free from the atom. It is then a free electron. The flow of free electrons is electricity. Different types of materials require different amounts of energy to free electrons. An insulator requires a really large amount of energy, a semiconductor requires a medium amount of energy, and a conductor requires minimal or no energy to free electrons. Imagine that you are an electron. To become free, there is a wall you need to get over. In a conductor, the wall is very short and you would easily jump over. In a semiconductor, the wall is higher and you cannot just jump over it. You would need a pogo stick to bounce yourself over. In an insulator, the wall is very high and you would need a giant trampoline to bounce yourself over. Solar panels are made of semiconducting elements and require photons with a medium amount of energy to free electrons. Currently, solar panels cannot use all photons that are emitted from the sun, but they can use many of them. Scientists are looking for materials that can use more available photons, creating more electricity. Check out our other videos about electricity, heat, and fuel. From solar energy to fuel. Energy travels from the sun as particles of light called photons. Photons are packets or envelopes of energy. Plants and some other small organisms such as plankton use energy from photons as part of the process of photosynthesis. During photosynthesis, energy from photons is stored in the tissues of these organisms as chemical bonds in glucose or sugar molecules. When an animal eats the plant, energy from these bonds is used as fuel for growth and other activities. This transfer of the energy through chemical bonds happens all the way through the food web. When we use the energy in chemical bonds from living or recently living organisms as fuel, it is called biomass. Burning wood is an example of using biomass for fuel. If plants or other small organisms become buried for millions of years, they may become fossil fuels such as coal and oil. We burn coal, oil, and natural gas for energy. Because coal and oil take millions of years to form, there is a limited supply of both. Scientists are looking for more renewable ways of using solar energy as fuel. Check out our other videos about electricity, heat, and energy. From solar energy to heat. Energy travels from the sun as particles of light called photons. Photons are packets or envelopes of energy. Different photons have different energies. All photons, especially low-energy infrared photons, can cause objects to heat up. We cannot see light from infrared photons. When a photon hits an object such as a car, the energy from the photon is transferred to the molecules in the object. This increases the kinetic energy or movement of the molecules, making the object feel hot. An increase in kinetic energy can also cause an object to change shape and state. When photons strike a piece of chocolate left in the sun, energy is transferred to the molecules, causing them to move faster. When they move fast enough to lose their solid structure, the chocolate melts into a liquid. Photons from the sun also cause wind on Earth. Different materials on Earth heat up at different rates. Energy is then transferred to the surrounding air. The more heat or kinetic energy in the air, the more the molecules move around and the more space between the molecules. Hot air is less dense and therefore rises, while cooler, denser air falls to take its place. This is known as convection and is what causes wind. Scientists are looking for ways to use wind as a source of electricity. Check out our other videos about electricity, fuel, and energy.
The sun, bringing life to our world, fueling our energy future, and powering a new era in clean, abundant, renewable energy. Here in Nevada, we invite you to see the future in reflection. Nevada Solar One.
The opening of the Nevada Solar One plant is a historic moment.
We're using the sun's energy to produce power in a large-scale power plant that will, in fact, benefit future generations.
I've never built anything that I was as proud of as this project.
This is well beyond just one power plant. It's revolutionary. And it's reality today.
Spread across a desert valley just south of Las Vegas, shine the gleaming mirrors of Nevada Solar One. The 400-acre facility generates 64 megawatts of electricity from the sun's heat. a showcase of clean technology known as concentrating solar power. Brought online in June 2007, Nevada Solar One is the latest innovation from Acciona, one of the world's largest providers of renewable energy.
Helping to solve the world challenges, making sustainable our way of life, and contributing to social progress is the most fulfilling and satisfying reward for my 38,000 colleagues at Acciona and for myself. It is what we feel proudest about and what makes our professional life one truly worth living.
We view ourselves as pioneers in development and sustainability. We're into wind energy, biofuels, photovoltaics. Essentially, we're trying to make these technologies large-scale commercial successes. And I think Nevada Solar One is a perfect example of that.
And we thought it was both an opportunity and an obligation to prove the viability of this sustainable form of energy.
Very simply, what we do is we take these parabolic trough collectors and they focus energy on a small little pipe. It concentrates the sun approximately 70 times. Inside that pipe, we have a heat transfer fluid. That then exchanges its heat with water. That makes steam. The steam runs a steam generator, which spins and makes electricity, which goes out into the homes of Las Vegas.
It had been more than 16 years since any new concentrating solar plants were developed, until Acciona seized the opportunity.
Over 4 years ago, I received a call saying, "You've really got to look at this," and I realized this was one of the best kept secrets in the desert.
And that was the beginning of a process, a long process, a process of finding the right partners and to start construction.
The project has attracted a lot of interest, people that want to come and see this technology at work.
Just like pioneering in technology, building and financing the first project in over 16 years required some pioneering in the financing world as well. But we were able to attract a blue chip group of financial investors who are devoted to making investments in renewable energy.
We have the potential in the U.S. between wind energy and particularly solar thermal to generate 30% of our energy from these renewable sources. So it's important that we try to provide a nurturing for these technologies.
Acciona's long-term commitment to sustainability means that we have to be loyal to its three main objectives: economic growth, social progress, and of course, environmental balance. That's where renewable energy comes in. Renewable energy is the cornerstone of sustainability, as it makes compatible economic growth and social progress with environmental balance.
The energy produced at Nevada Solar One is purchased by local utilities, Nevada Power and Sierra Pacific Power, under long-term agreements.
I commend Acciona for taking this technology and making it into a commercial operation that's benefiting all of the state of Nevada. Solar power doesn't produce any greenhouse gases, so that's good for the environment, and that's good for our customers as well.
What Nevada Solar One does is it helps us get off of that foreign oil dependency. It not only is it helpful in our economic security, but it's helpful in our national security as well.
I envision that we as a country need to make solar as big of an issue as our space program. And so I'm excited. It's an awesome thing for Nevada and for the country and if not the world.
It is a major breakthrough in energy independence. It is hugely scalable and it produces its energy only a few miles away from where it's consumed. For the local communities, it opens a whole new universe of industrial opportunities in components, services, and general know-how. And all that while contributing to solve climate change, one of the world's most pressing challenges.
I do believe we're doing something good to the world and making it better for future generations. Certainly want to see more of these plants scattered throughout our planet.
Nevada Solar One is the first plant that was built in 16 years. We're not going to wait another 16 years. The next one is coming just behind it.
We want to lead the development of this industry the same way we led the development of the wind power industry. And Nevada Solar One is the first step towards that leadership.
Renewable energy technologies like concentrating solar power create new jobs, provide local economic development benefits, offer cleaner, more diverse fuel sources, and prove that America is committed to reducing our carbon emissions. It's a new energy era. Nevada Solar One is reflecting what's possible today for our environment, our security, our economy, and our tomorrow. Nevada Solar One. See the future in reflection.